Okay, yesterday we started understanding the concept of inheritance, and we saw that in the concept of inheritance, we can get the features from one class to another class. So that is possible by using a keyword called extends. When I use a keyword called extends between two classes, they become a parent and a child, or they will have a parent and child relationship between them. Now, the same example, I will take it to the next level and try to explain the concept of abstract class in Java. Okay, let me create a package again, com.easylearnjava.abstract demo, and I've created a class called shape. Okay, so now in this shape class, let me say that I want to write a method. Okay, so before I write something in shape class, let me do or let me create two more classes like a circle class and a rectangle class. So in this circle and rectangle class, the main focus of this three classes is like shape, circle and rectangle is I would like to explain the same concept of inheritance. So what I want to do is I want to figure out what are all the common methods that circle and rectangle classes will contain. Those methods I would like to pull out and place it under shape.java so that once I write the code in shape.java, I will say circle extends shape and rectangle extends shape so that circle and rectangle can get all the similar features from one common location, and I need not duplicate the code again and again in these classes. So in shape.java, let me create a public method. So for time being, let me say, write a simple dummy method, public void print color. Okay, some logic I will write here, and I will say that let us assume that by default all the objects when I create them or when I make them are in the color or in white color. So I just write something like this out white color. Here I write from print color in shape class. Okay, let us assume that that is a method which is common to both the classes circle and rectangle. So now means whatever concept I am explaining right now is the same old concept that we understood yesterday. I create a class called demo and I go back to circle and say circle extends shape. Okay, and rectangle extends shape, which means circle and rectangle get all the features from the shape class. So in the shape I do have a method called print color. Now in demo.java, when I try to create an object for a circle, how many methods I can call? What is the answer, team? 1. Very good. Okay, now when I create an object for shape, how many objects I can call? Sorry, how many methods I can call? 1. Very good. So in each scenario, yeah, Praveen. See here, Praveen. When I create an object for shape, it is only one method that I can call on this shape class, that is nothing but print color. Okay. S dot print color, and even circle also I say C dot print color, and print color is a public method which is not taking any arguments as input and which is returning back nothing. So it is void and it is present in the shape class. Okay, print color or R dot print color. Okay, everything is good. This is what we saw yesterday. Now let me add few more concepts on top of it. The next scenario, why we are creating a class called shape? Why? Because the shape class, which is a parent class in the hierarchy, can define all the common set of methods in it so that I can reuse the code without duplicating in subclasses. Well and good, everything is clear till that point. Now answer this next question. I want to write a method like print, sorry, public double calculate area. Okay, this is the method that I want to write. Now can someone tell me what is the formula that I need to write inside this calculate area so that that functionality can suit to every object out there, like for circle also that must suit, or rectangle also that must suit. Can someone tell me what is the logic that I need to write at line number 10? Or what is the formula for calculating the area of a shape? Okay, my question is, what is the formula for calculating the area of a shape? X into y. Okay, so x into y is it the formula for calculating the area of a shape or circle or a rectangle? Rectangle. But if I write x into y here, let us assume that I write x into y. Will this logic suit for my rectangle.java class, Sai, or anyone? Will that suit for my rectangle.java class? Yes, very good. It suits for my rectangle.java class. But will it suit for my circle.java class? As simple as that. No, which means what is your main target in creating a parent class and writing the functionalities? Your target is to make sure that the common logic is written in shape.java so that it can be used across every child class. But when I say x into y, it means I'm writing an implementation for a rectangle class, which means I'm not writing a generic code. I'm writing some specific code related to rectangle, which is not a valid scenario. Okay, so writing x into y is not valid. Now, the next, so for the answer for the question, like as I think Adi, someone already told rightly, we don't know how to calculate the area of a shape. That's correct. Now the next question, do you know how to calculate the area of a circle and how to calculate the area of a rectangle? Yes, as simple as that, which means in the current context, of shape, we don't know how to calculate the area of a shape, but in future, if there is a new object that is being created, like either a circle or a rectangle or a square or a triangle or what, a formula for calculating the area of that specific shape. But in this context, you don't know, but in future you will definitely know that, right? So what I do is I say that, okay, in future there will be a method which is like calculate area for sure, but in the current context, I don't know the implementation. Okay, in the current context, I don't know the implementation. So in those scenarios, I will try to create something called as abstract methods, a method which you don't know completely, or for a method which you don't know the implementation. Implementation means, see, for line number 5, the method at line number 5, whatever I write inside these brackets is called as implementation. And since I wrote an implementation for a method called print color, these are called as concrete methods. Concrete methods are something which are well defined with a body. Body is nothing but something you write between these brackets since you know the implementation. But currently for calculate area, we don't know the implementation, which means we cannot write a concrete method called calculate area. But for sure, we can write a method called calculate area. So what I do here is public double calculate area, right? Notice the specific changes that I'm going to do for the method which I'm defining at line number 14 and the method I have defined at line number 10. Okay, so I write brackets, then instead of writing curly braces, I write a semicolon at the end, and I add a keyword called as abstract. Okay, so the meaning of this syntax is, hey, for this calculate area, I don't know the body, or I don't know the formula for writing or calculating the area of a shape. So there is no body. So I made it as, means I removed the body and added a semicolon, and I wrote a keyword called abstract, so that that abstract keyword tells that this specific method is not a completely defined method. Okay, so this is how you write abstract methods. So the one which I defined at line number 15 is an abstract method which is defined using the keyword called abstract and with a semicolon at the end, and the one which I defined at line number 6 is a concrete method which is identified by writing curly braces, and it means you are writing an implementation there. Okay, abstract method. Now the next thing, the first thing that you need to notice here is how to write a concrete method and how to write an abstract method. Now in a class, till now, okay, till now what we saw is like every class that you created has only concrete methods. Till now, that is what we saw. Okay, so if suppose if I take any other class, let me say like go to something like account.java. Now quick question to everyone. In account.java, are there any abstract methods? Very good. The answer is no. The next question. Is account a concrete class or an abstract class? Very good. It's a concrete class, which means it is a well-defined class with all the methods implemented in it. Okay. Now, coming back to shape.java. In shape.java, I will explain the concept of abstract class, but I'm asking a question. In shape.java, do you see if it is a concrete class or an abstract class? Any guess? Very good. It is an abstract class. Why? Because there is a method which is not yet defined, or not all the methods are concrete. Okay. So since not all the methods are concrete, you are defining this method as abstract. The class also becomes abstract. If you notice, after I wrote an abstract method, it started showing an error at line number 3. Why? Because it started complaining saying that, hey, this class does not have all concrete methods. So better go back and define the class also as abstract. Okay, so now see here, the error is gone. Why? Because the fundamental concept here is, if a class has at least one abstract method, then the class must be defined as abstract. Okay, why? Because if there is an abstract class, it means it is not a concrete, or if it is not a well defined class. Since it is not a well defined class, you need to make that class as abstract. Clear till this point? And is it clear to everyone, like when you need to make a class as abstract? Okay, very good. Now then, going back to the next concept, one more question to everyone. Can I create, okay, so everyone knows that the class account is a concrete class. Now can I create an object for a concrete class? Yes or no? Awesome, yes. Okay, think before you answer the next question. Can I define an object for a shape class or an abstract class? As simple as that. The answer is no. Why? Because if you go back to the same old example of a house which is being constructed based on a design, let us assume that you go to an engineer. Okay. So when you go to an engineer, the engineer says that to the engineer you say that, hey, I want a house which looks like something like this. The front elevation will be like this. It has a garage, and so the engineer or the architect, he might give you a rough design of how the house might look like, but he might not give you the exact dimensions of the house, exact dimensions of the hall, exact, he might not give all the exact dimensions. If he did not give all the exact dimensions, can the builder construct the house with that abstract design given by the architect or not? As simple as that. The answer is no. Why? Because since it is an abstract view, the builder will not know how big the hall should be, how big the kitchen should be. Why? Because the architect just now gave us an abstract design or a high level design, right? So the same case, if a class is abstract, you can never ever create an object for an abstract class, the most important thing in Java. Okay, for an abstract class you can never create an object. Okay, now before I proceed to the next concept, I just want to reiterate the concept, like with a different example, or I can define with the same example. See, in a class, if there is at least one abstract method, then the class must be abstract. Okay, that is the base concept that you understood right now. But now what I can say here is, new class, I just created a test class. See, a test class is concrete right now. So as per our understanding, when can this test class become abstract? When there is at least one abstract method. But even without abstract method also I can make the class as abstract. See here. Okay, but ideally it doesn't make any sense to make a regular class as abstract. Okay, only if it has an abstract method, then we declare the class as abstract. And here I would like to define a few concepts, like ABS. An abstract class can contain, so but this is of no use, I'm just explaining. An abstract class can contain zero methods. Okay, or an abstract class can contain, see here, public void m1. M1 is a concrete method. Okay, it can contain only concrete methods. Okay, see, my class has only concrete methods in it, m1, m2, or whatever. I can define more. Public void m2. So both m1 and m2 are concrete methods. Or see, I'm trying to explain the scenarios in which you can create an abstract class. Or it can contain only abstract methods. It should not have body, so let me remove the body. Say semicolon, remove the body, and say semicolon. Okay, so an abstract class can contain only abstract methods, or a combination of both concrete and abstract methods. Public void empty. So I have two abstract methods and one concrete method. Okay, so this is just for your understanding purpose, like in which scenarios you can create an abstract method class. Okay, but the basic concept that you need to understand is, if a class has at least one abstract method, then the class must be abstract. And the next important concept that you understood is, any abstract class you create, for that you can never ever create an object. Okay, so 2 points, those 2 points very important. Now, can someone tell me why line number 7 is causing an error? Shape is not defined completely. Okay, yeah, that's good. That's good. Since shape is a concrete class, you cannot create an object for a concrete class. Okay, so first line number 7 is clear to everyone. Now the next question: why is circle showing an error? Anyone? Okay, it is extending shape. So what happens when it is extending shape? Okay, awesome. So shape shape is abstract. So since circle is also extending shape, okay, yeah, very good team. So understand the concept here. When circle is extending shape, answer this question: how many methods circle will have right now? Or how many methods circle will inherit from shape? All methods in shape. Very good. Now the next question: if it inherits all the methods, how are there any abstract methods which it is inheriting? Yes, okay. So now how many methods? Everyone told that it inherits two methods are inherited from the shape class. Okay. Now the next question: in those two methods, how many methods are concrete and how many methods are abstract? One each. So out of the two methods, one is concrete and the other is abstract. Now the next concept: what is that we understood, like if a class has an abstract method, Will the class be concrete or abstract? What is the answer? As simple as that. Okay. If a class is abstract, if a class has an abstract method, then the class must be abstract. So public class, public abstract. Okay. So did it resolve the error? Yes. Okay. Now the next question to everyone. Is it a valid scenario to make the class circle as abstract or not? No. Okay. What about others? No. That's good. So let's take a simple example. In real world, when I say shape, what exactly comes to your mind? I just I just said shape, nothing else. Which shape comes to your mind? Is it a circle? Is it a rectangle? Is it a square? Trapezium? Which one? Which means that we cannot specify which shape I am talking about, right? Which means it is an abstract view that I'm telling. So you cannot get an idea of what exactly is that shape means. But when I tell circle, can you imagine a circle in real world? Yes, you can imagine a circle in real world, which means in real world, since you can imagine, you can create an object for that which you are which you have which is called as a circle, right? So which means making a circle abstract is not a valid scenario. So what exactly you make abstract? Something which you cannot ideally think of or made abstract, but something which you can ideally think can be made as concrete classes. So if I say circle, you can correlate that circle with either the wheel of a cycle or a cricket ball or a football or whatever, like that you can assume or you can correlate, right? So this solution, whatever I have written, like making the class circle as abstract is not a meaningful solution. So I don't want to make circle as abstract. Why? Why? Because since circle, I know how exactly circle looks like, and I must be able to create an object for circle. But if I make circle as abstract, I can never ever create an object for circle. So I don't want to do that. So the solution which we just thought of is not a valid solution. Okay. Now, what is the other solution that can help us in resolving the issue at line number 3? Anyone? Overriding. Awesome. Excellent answer. Okay. So the next concept that we will implement here is overriding. Okay. Before I explain the concept of overriding, let me just go back one step and reiterate the overriding concept that we saw in yesterday's class. Okay. So in yesterday's class, we defined some hierarchy like account, which is of parent class, and savings account. So what exactly is a savings account? It is a child of this account class. Now, in account class, there are two methods like get account balance and get interest rate. Now, in savings account, if I rewrite the same method again, that concept is called method overriding. Now, answer this question. By overriding the get interest rate, will this method present in savings account, will it hide the account class get interest rate or not? Yes, awesome. So what is overriding doing? Overriding, it helps you in writing your own logic here. So the parent class features, and it will give the current class features to you whenever you create an object for savings account, right? Now the same concept holds good here also. So what is that I want to do? I want to hide the abstract method defined in the parent. So if I want to hide the abstract method defined in the parent, what is the way that I can hide a method? By using method overriding. So what is method overriding? Rewriting the same method again in the subclass. So I will write the same method, defining the same method again. So I will define the same method again. So now if I define the same method again here, will it solve my problem? No, it will not solve my problem. What is that I want to do? Instead of creating that method as abstract, I want to make that method as concrete. Okay. So the next question to everyone. In order to make the method as concrete, I must know the implementation of this method. No, now, do I know how to calculate the area of a circle or not? Yes, awesome. We know how to calculate the area of a circle. That is nothing but pi r square formula. So instead of making the the method as abstract, I write a definition for this method. Okay. So for that, what I do, I need a radius. So private double radius. So I'm defining a property for this circle and say source generate getters and setters. And here all I do is return 3.14 into radius into radius. Okay, this is what I defined. 3.14 into radius is what I'm trying to do here, which means that I know the formula for calculating the area. So this is how I do it. Now the next concept, rectangle. Even for rectangle also, what will I do? I will re-implement the same old method called calculate area. So what is the area for calculating the area of a rectangle? What is the formula? L into B. Private double length private double right. Now I create getters and setters. So what is that I return? Return length into breadth. Okay. So there are two things that I did here. One, implementing the method so that I can write some code inside it. I can write some logic to make the method calculate area as a concrete method in both the classes. In circle I made it as concrete and rectangle also I made it as concrete. Now the next question to everyone, how many methods the rectangle class has right now and what are those methods? Very good. Rectangle class has two methods now. The two, it's not okay. I'm sorry to confuse you. Like if you think that get length, set length, these are also methods. Maybe at this point, I'm not talking about the getters and setters. I'm only interested in talking about the main methods, which are nothing but calculate area is one method, and there is one more method defined in the shape class, which is nothing but print color. So there are two methods in the rectangle class. One is print color and the other one is calculate area. So these are the two methods in the rectangle class. Now in circle class, how many methods are there? I'm not interested in getters and setters. Again, I'm telling. Again, it has two methods, calculate area and one more method which is present in its parent class called the print color. Okay. Now, the next question to everyone. Can the circle class see the calculate area present in the shape class or not? Very good. It cannot see. Why? Because the concept that we use here is method overriding. Because of method overriding, the concrete calculate area method in the circle class hides the abstract calculate area method present in the shape class. Okay, clear with this concept till now to everyone? Okay, very good thing. Now, going back to the next step. So everyone knows that when I say shape s equal to new shape, okay, you all know that I cannot do this because shape is an abstract thing. So since shape is an abstract thing, I cannot create an object and I cannot correlate to some real world thing. So shape is defined as an abstract class. So line number 7 cannot be written. Well and good. Now, the next question. Can I create an object for circle class? Awesome. The answer is yes. Why? Because circle has all concrete methods right now. Okay, circle has all concrete methods right now. Now I can say C dot calculate area and R dot calculate area. See right now, see here, when I say C dot calculate area, it shows it is a public method calculate area which is not taking anything as input, but it returns back a double as output and it is present in the circle class. Okay. And for line number 16, it shows the same old concept and it says that it is present in the rectangle class. So let me do one thing. Since I have created an object called C, circle for C, a reference variable, I say C dot set radius. The radius that I am setting is 5. Okay. Now I do a sys out. Area of a circle I do. The same way, since I have created a reference variable R dot set length, I say 2 and R dot set breadth as 3. I am doing and I say sys out area of a rectangle. Okay, R dot calculate area. That is what we do. Now, if I try to run this, it calls the calculate areas which are present in those respective classes and gets you the output. Say for circle it is 78.5 and for rectangle it is 6.0. Okay. So now the next concept. I'm going to explain the concept of, okay, let me take that question from side. Is this the only method to avoid abstract error? Okay. So don't assume like is this the only method. The concept for you to understand is how many, what is the answer? How many? Anyone? How many, okay, my question is, how many abstract methods are there in shape class? Okay, awesome. One method. Now, in order to make a child class in order to make a child class concrete, how many methods you need to override? Awesome. Next question. If I have a shape class with three abstract methods, understand the question carefully. If I have a shape class with three abstract methods and two concrete methods, okay, how many methods will a circle class inherit? Okay, circle class inherits five methods. Okay, five methods. Well and good. Now, my next question. If I want to make circle class as abstract, sorry, if I want to make circle class as concrete, how many abstract methods I need to implement out of three abstract methods and two concrete methods? Awesome. I need to implement all the three abstract methods in order to make the circle class as concrete. So the answer to your question is, it's not just a calculate area that you need to make abstract, or it's not just one method. If the parent has 10 methods, and if you want to implement, or if you want to make circle as concrete, then you must implement all the 10 abstract methods here. Okay, if suppose, understand the next scenario. Okay, the next scenario is, if shape has 10 methods and out of those 10 methods, 8 methods are abstract. Okay, 8 methods are abstract. Now, in a circle class, if you say that, hey, in circle, there is no compulsion that circle must be concrete. Why? Because out of the 8 abstract methods, I only know the implementation for 5. I don't know the implementation for 3 abstract methods. In that scenario, you will still make your child class as abstract only. Why? Because you don't know the implementation for the 3 abstract methods. So you implement whatever methods you know, and you leave the rest of the methods as abstract. So since your class has 3 abstract methods, it must become abstract again. So there is no hard forced rule that every child class must be concrete. It all depends on the scenario. If the child class knows all the scenarios, then make it as concrete class by defining everything. But if the child class knows only 4 implementations for for 4 abstract methods, if it does not know the other 4 implementations, your child class will still become an abstract class. Clear with that concept? Okay, very important concept.
Yes, Raghu. My question is that can I avoid that abstract method in my class? So instead of overriding this, can I avoid it by any
Okay,
other means?
okay. So if you extend, what does that mean?
Yeah, it gets all the methods
Yeah.
in the shape class, but my question is, I'm just viewing this as a big project. Like we just have 3 classes and 2 methods in shape, right? So if I have like 100 classes and 100 methods in shape, and I can declare 99 methods of the shape, but not only one method, which is an abstract one. But the best way is I can use the shape class completely with the 99 methods, but that one method is creating me a problem, right? So is there any alternative to just avoid that method and use shape class?
The answer is no, but it is not creating a problem. Why? Because let us assume that when someone says that shape, so if you have 100 methods in a shape, then it means that you are defining all the features for a shape at one common location. Let us assume that shape is not there in the current scenario. Okay, so 5 people join the project, and for 5 people there are 5 different tasks which are given. So the tasks are something like, someone will say that uh, for first person, create a circle class and write some methods in it. Then for second person, create a rectangle class. For others, create a triangle, square, like that. 5 people will get 5 different classes, and they will try to write some methods in them. So as a developer, you might think of some 10 methods in circle. So you implement 10 methods. As the second one, as a developer, he might think some other different methods, 10 different methods, or 5 common methods which you have thought of, and 5 different methods, which means out of the 100 functionalities, you are able to think of only 10, 20, or 30 functionalities. What about all other functionalities? You are missing out all the functionalities. So what we do during the design is, we create all the common functionalities in one single class, so that anyone in future, if they say that, hey, I want to create a triangle class, then if they want to know what are all the features the triangle class can contain, then they go back and take the reference of the parent class and see that, okay, parent class has 100 methods defined in it, which means all those 100 methods exactly or must suit to this child class called triangle. Then only it becomes a child class for the shape. If not, it will not become something child class for shape. So you cannot avoid it by defining an abstract method. It's something like you are defining all the contracts here, which means how many types of functionalities that the child classes can have, and those functionalities you are all declaring it at one common location, which is like a reference to everyone out there who is coming. So tomorrow, even if you want to create a triangle class or a square class, you can know that, okay, what are all the types of properties or features that a square can contain. Then you say that, okay, the parent class has these types of methods, which means they all hold good for the upcoming classes. That is how you think. And why concrete method? Sorry, why abstract method? Why? Because in the current instance, you don't know the implementation, but in future, for the children, you definitely will have the implementation that you need to write. So that is the reason why you make methods as abstract. I hope at least this gives some more insight for you, Sai, and for everyone. Okay, yeah, that's good. Now I would like to explain the concept of polymorphism in this concept also. Okay, so everyone knows that whenever, okay, maybe let me just go back one step to the polymorphism that we understood in yesterday's class. In yesterday's class, in the case of polymorphism, what I did is I created an object of for an account class. So an object of type, a reference variable of type parent, and it can point to either a parent object or any child class objects. That is what we saw in yesterday's class. But in the current scenario, can you create an object for parent class? Yes or no? The answer is no. We cannot create an object for parent class. Then many people might ask the question, then what is the use of that abstract class, or can you use an abstract class? Yes, you can use the statement that I'm trying to say here. I can create a reference variable of type parent which is pointing to a concrete child class. Understand the concept. The concept is concrete child class object. So is circle a concrete child class? Yes, circle is a concrete child class. So I say new circle. Now the next question, answer this. Can SH point to a rectangle object or not? Okay, the answer is no. Can you tell me, Sandeep, why no? Sandeep, what is the answer? Okay, good. So what is my question? My question is, can I say SH equal to new rectangle? That is what I told. It can do that. Why? Because there is a relationship which we have already defined. Okay. So I say SH is a reference variable of type parent which is pointing to a concrete child class. I can do this also. Okay. Now, before I ask the next question, just understand the scenario that I have created just now. I created a class called temp, which is a child class for shape. Okay. Temp is a child class for shape and temp is an abstract class. Why? Because I am not implementing the unimplemented method, or I am not implementing the abstract method called calculate area in this temp class. Okay. So with that understanding, tell me, can SH reference variable point to a temp object or not? Very good. It cannot point. Why? Because temp is an abstract class. So our concept is a parent class reference variable can only point to a concrete child class. So SH equal to new temp, this concept is wrong. Okay, so this cannot be done in Java. Why? Because this is of type abstract and this is also an abstract class parent variable referring to the parent abstract class parent. So this concept is wrong. Okay, so is everyone clear with the concept of uh, polymorphism with abstract classes? Okay,
Can you go once again there?
yeah, sure, definitely. So the concept of the polymorphism is with respect to variables. What is that? If I go back and explain the polymorphism concept that we saw yesterday, in yesterday's class, there are multiple classes that we have created. One is an account class, and for account, there are two children which I have defined. Either a savings account is one child or checkings account. So both savings account and checkings account are children for account class. So now to explain the concept of polymorphism, yesterday what we saw, we created a reference variable of type parent, and that object, that reference variable can either point to an account object or it can either point to a savings account object or it can point to a new checking account object. Okay, so either of these things, these objects, the account reference variable or a reference variable of type parent can point to. So well and good, that is what we saw yesterday. But in today's concept, when I'm trying to write something like line number 25. Okay, so what is line number 25? Creating an object for parent class. Okay, when I try to do something like line number 25 in today's class for shape, it is not allowed. Why? Because shape is a concrete class. Okay, that is fine. But still, can I achieve polymorphic feature in this concept? Yes, I can achieve. So how I can do that? I can say a reference variable sh, which is of type shape, can only point to a concrete child class object. So now, how many child classes are defined for shape? For shape, there are three child classes. One is circle.java, the other one is rectangle.java, and the other one is temp.java. Like this, there are three classes which are defined. Now, out of these three classes which are defined, how many classes are concrete? Only circle and rectangle are concrete. So now, if I create this sh reference variable which is of type shape, can I point it to circle and rectangle? Yes, I can point it to circle and rectangle because they are concrete. Can I point it to temp? No. Even though temp is a child of shape, still I cannot do this because temp is again an abstract class. So since it is not a concrete child for shape, I cannot say new temp. Clear? Okay. Any doubts before I proceed? Yeah, that's a good question. So circle C equal to new circle you can use at any point of time, or rectangle R equal to uh, R equal to new rectangle. This you can use at any point of time. But ideally what we do is, instead of creating different variables and calling the methods and setting the variables and doing all this stuff, instead of doing all these things, what we do is we try to code it to the parent class. Okay, so sh is of type shape. So since sh is of type shape, it can hold any of its concrete children. So instead of creating circle c equal to new circle or rectangle r equal to new rectangle, if you have a hierarchy like a parent and child relationship, you will create a reference variable of type parent, and to that parent you can refer as many children as you want. So instead of every time creating new reference variables, you can use the same reference variable every time you want. Clear? Okay, yeah, that's good. So now what I will do is I will try to explain some of the concepts related to constructors right now. And why? Because yesterday, the day before, when we saw the concept of constructors, we just try to understand one level. When I say one level, so I created a student class, try to create an object for student class, and saw how the constructors are being called. Now what we will do is, we will try to extend the concept of constructors to multiple classes which are in a hierarchy. Okay, that is what we will do. So the next thing that we will observe here is like constructor chaining. And in constructor chaining, let me write a class called machine. Okay, or instead of machine, let me make it as a car class. right now in this current concept, I'm not interested in explaining any methods. We will look only into constructors. Okay. So the next thing that I say is Mustang, and Mustang extends car. Okay. So every time I can write or hard code Mustang extends car, something which means the extends car I can either hard code or I can use a different shortcut here. See here, when I create a class as a challenger, and the super class that is present here, I say the car. Okay, I say the car and say finish. So did you notice here? This is automatically written for me by Eclipse, just a feature that I'm using. Okay. So now Mustang extends car and Challenger also extends car. There are two things that I wrote here. Now let me add some constructors to them. Constructor will have the exact same name as the class name. This is out class constructor. Then let me add some parameters if I want, like public string str. Then I say this out class parameterized constructor. Okay, just wrote two constructors in car. The same way I will write two constructors in Mustang. The same way I will write two more constructors in Challenger. Okay, now created two constructors in every class, car, Mustang and Challenger. Okay, so now Mustang extends car and the Challenger also extends car. Now let me write one more class for the demo. Main method. Okay, so now I'm creating an object for car class. Car equal to new car. Okay, so from now onwards, okay, understand this and answer the questions. So every time I ask an answer like which constructor will be called, so assume that the first constructor is number one and the second constructor is number two in every class. In this one, 1 and 2. In this class, 1 and 2. Okay, so when I ask which constructor is called, tell me an answer like either 1 is called or 2 is called, like that. Tell the numbers. Okay, so tell me the number which constructor will be called in this context. Awesome, 1 will be called. Okay, I run it. So car class default constructor, very good. This out. Now I say car C1 equal to new car of which constructor will be called? Number 2. Okay, yeah, second class constructor will be called. Okay, awesome. Second constructor. Here is the tricky part. I already told that it is tricky, so think before you answer. I say Mustang M1 equal to new Mustang. Okay, don't just say one or two. Think before you answer. What will be the output for line number 13? If you say 1, that's definitely the wrong answer. Any guess? Any clues? Since 1 is the wrong answer, don't say 2. 2 is also the wrong answer. So the constructors that are called are nothing but 1 and 1. So what is meant by 1 and 1? It means, what is that I'm calling? I'm calling Mustang M1 equal to new Mustang, which means everyone knows that when I say Mustang, it calls the default constructor in the Mustang class, which means this is, as per our understanding, this is constructor number 1, right? So apart from this constructor, since the Mustang is extending the car class, it goes to the car class, and in the car class it calls the default constructor again, which means this is the one which will be called. So every time in the scenario, understand the concept. Okay, whenever you are trying to create an object for Mustang, you assume that the Mustang constructor will be called. Okay, that's correct. Mustang constructor will be called, and even before line number 6 is executed, okay, even before line number 6 is executed, the Mustang constructor will check if there are any parent classes or not. Yes, there is a parent class called car. So it goes to the car class default constructor and calls the car class default constructor. So the output would be P1, which means parent class constructor 1, then followed by C1, child class constructor 1. Okay, or else instead of child class you say M1. So P1 for parent class, which is nothing but the car class constructor 1, M1 for Mustang class default constructor first one. Okay, so now if I execute this, notice the output, car class default constructor, which is P1, and P for parent, parent 1, then the Mustang class default constructor M1 will be called. Is this clear to everyone? Okay. If I want to call Mustang default, okay. So the concept is we are calling Mustang default only. We are not calling car class. But in Java, since the Mustang class inherits from the car class, so before a Mustang class is present, you must have a car class. If the car class is not created, then from where exactly will you inherit the properties? You cannot inherit the properties from something which is not there, right? So you inherit the properties from the car class. So the car class object is created, and also Mustang object is created after that. So that is the reason why whenever you call the default Mustang constructor, it calls the default car class constructor. So this will be created first, and then the Mustang default constructor will be created. So basically the concept here is Mustang. If you call this one, it checks if there are any parents in the hierarchy, then go to the parent, create that object, and then create the child object. So first create the car object, then create the Mustang object. That is how it happens. So the answer for this concept is P1 and M1. Okay. Now, if that concept is clear to everyone, answer this question. Mustang P1, yeah, either you can say C for child 1 or M1 for Mustang 1. Okay. Mustang M2 Mustang MM equal to new Mustang of Sport. Okay. Now, tell me which constructors will be called. P2 C2. Okay. P2 C2. Okay. As expected, that's the wrong answer. Okay. But based on the previous concept understanding, I expect that everyone will tell the same answer, but there is a slight tweak here. Understand? Okay. So, what is the constructor that I am calling at line number 16? I am calling a constructor which is parameterized. So, I am calling child class second constructor. Okay. This one, the one at line number 9. It is clear to everyone. So, first that is being called. Now, before I explain the next concept, question to everyone: will this constructor be called right away, or will line number 10 be executed right away, or will it call someone else? Okay, the answer is wrong. Again, you need to understand the concept. Call someone else. That is the right answer. Why? Because whenever I am creating an object by calling the constructor at line number 9, it means I am trying to create a Mustang object. Now, when I want to create a Mustang object, so is Mustang extending the features from anyone else? Yes, it is extending the features from someone else called as car. Okay, so yeah, Vindhya, I'm just trying to repeat it. So do you want me to repeat the previous scenario or if the current scenario? Which one do you want me to repeat for line number 30? Okay, that's good. So let me repeat for line number 13 and then come back to line number 16. So at line number 13, when I call the constructor for Mustang, it means this constructor is being called. So the constructors are called during object creation. So if you want to create an object for Mustang, are you extending the features from anyone else? Yes, you are extending the features from the car class also. Since you are extending the features from car class, hey, where is the car object? Did you create a car object? No, you did not create a car object. So first go to the parent and see if the parent object is created or not. If not, create a parent object. So whenever you call this default constructor, it calls the parent class default constructor car. So this line number 6 will be executed first. So that is the reason why line number 6 is printed here. And once the car class object is created, then the features of the car class are inherited to the child class. So next the child class object will be created. So line number 6 here is printed next. Okay. So that is the call hierarchy for line number 13. So is it clear first of all, Vidya, and to everyone? Okay, good. Now the next concept. The same concept holds good here also. The only difference is here I am calling a default constructor, here I am calling a parameterized constructor. At line number 16, when I call a parameterized constructor in Mustang, it means I am calling this one. Now, when I am calling that line number 9 constructor, it checks, does this class extend from anyone else? Yes, it extends from a class called car. So it first, instead of executing line number 10, Okay, instead of executing line number 10, it goes back to the car class, and in the car class it calls the default constructor only. Okay, uh, don't assume that when a default constructor is called, this parent default is called. So when I call the parameterized in child, don't assume that the parent class parameterized will be called. Parent class parameterized will not be called by default. It will not be called. So in Mustang.java, all you need to do is whenever you make a call to the parameterized constructor, it will only call the default constructor. It will not call the parameterized constructor explicitly. So the output would be first line number 6 in the car class will be executed, then it executes line number 10 in the Mustang class. So now if I go back to demo.java and execute this, see the output. First the car class default constructor is called, and then the Mustang class parameterized constructor is called. Okay, so the output is P1 but C2. Parent class constructor 1, child class constructor 2 are called. Clear to everyone?
It's a little tricky, but yeah, I guess. So like in order for us to call the car class, the second one, what do we use? The super class?
Yeah, we will see the concept next. Okay.
Okay.
Okay. Now the next thing is, by default always the parent class default constructor is called. That is what I am telling. Right now, let me do something. Let me remove these constructors. Okay, let me remove those constructors and let me write a constructor defined or given by the Eclipse. Means taking the help of Eclipse, let me write a constructor. Okay, so no, or else let me write a parameter. Did you notice here, when I created a constructor, the first statement in the constructor by default will be something called as super. Okay, when I say super, it means call the parent class or call the super class. Who is the super class for Mustang? What is the answer? The super class for Mustang is
Car.
car. Very good. So by default, call the constructor without any arguments. This is the first syntax which is by default executed for you. So if I revert back my code, in the code that I have written, there is never a statement called super or super which is written here. But by default, Java compiler inserts a super for you even if you don't write it. That is the reason why only the parent class default constructor will be called. See here, ideally the compiler assumes like this, super, super. This is how the compiler assumes. Okay, so whenever I call this Mustang, it calls the super class, which is nothing but the parent class default constructor. Or when I call this parameterized constructor, still it calls the parent class default constructor only. So now I made some changes. I wrote super and super, right? See, even if I write super or even if I don't write super, it will never ever make any difference for me. Why? Because the Java compiler will assume that super will be the first statement in a constructor, and by default it calls the parent class default constructor explicitly for you. So if it now run Java again, okay. So even if I go back and run demo.java, there is nothing much difference. So car class default, car class parameterized. Then when I say Mustang default, when I call, it calls parent default and Mustang default. Then when I call Mustang parameterized, then it calls car class default and then Mustang class parameterized. Okay, same old concept. Clear with this? Okay, now the next concept. Even if I write line number 6 and line number 11 like super and super, or even if I don't write, it will never make any difference. Okay, that's the first point. Now the next point is by any chance. Okay, by any chance, if the user wants to write explicitly a statement called super, like what I did at line number 6 and line number 11, if the user wants to write super, there is a clause for this. The user can never ever write the super statement as the second line or the third line, which means every statement or in a constructor, the call to the super class constructor must be the first line always. If you say that no, I will write it at second line or third line or fourth line, the compiler starts complaining, saying that a call to the constructor must always be the first statement only. That is what it starts complaining. Clear to everyone? If you don't write also, no problem. But don't write super after some statements in a constructor. It must be written always as the first line in the constructor. Okay? Clear? Okay? Awesome. Now, the next thing that we will understand is, by default, every time it calls the parent class super constructor or the parent class default constructor only. Now let us assume that I do have a requirement where from my Mustang parameterized constructor I want to call the parameterized constructor in the parent only, not the default one. If I want to do that, so instead of super, I just say super ABC, which means what is that I am trying to do? Hey, call the super class parameterized constructor. That is what I am telling. So in this scenario, this super of ABC can call the parameterized constructor instead of calling the default constructor directly. Okay. Now I'm interested in understanding the output for line number 16 only. What is the output for line number 16? P2 and C2. Okay, good. That's good. So if I execute car class parameterized constructor, then Mustang class parameterized constructor. So we are explicitly calling the car class parameterized constructor in this scenario by using a keyword called super of. Clear? Okay. Now I'm going to explain one more concept here. Is there any purpose of calling it explicitly? Yeah, that's what I am telling. If the business requirement is saying that, or in a logic that you are trying to implement, if you want to call a different constructor, is there a way, or did Java give an option for you to call a different constructor other than a default constructor? Yes, Java gave an option to call that constructor also. What is that? By using super of and passing the parameter. So based on your business requirement, either you can call a default constructor, or if you don't want to call, you can call a parameterized constructor also. It all depends on the logic, and it all depends on what you want to call. Okay. Okay. Now answer. Tell me the output for line number 9. Mustang. What's the output for line number 19? P1 and C3 is what someone told. What about others? P1, C3. Okay. Mustang class again. Yeah. This is the Mustang class. Okay. P1 and C3 is what everyone told. Let's see if that is right or wrong. So car class default constructor is called P1. Then Mustang class constructor with multiple parameters C3. So C3 is called P1 and C3 is called well and good. Nothing, no doubts, everything is clear. Now the next concept that I'm trying to explain here is, if suppose, okay, in the previous scenario, what did you understand? From a child class constructor, okay, understand very carefully. From a child class constructor, how can you call a parent class? Okay, there are two ways. By default, the parent class default constructor will be called because of the keyword super, and if you want to explicitly call the parent class constructor with some parameters, you can explicitly write super of something like this. So using super, you can call the parent class constructor. That is what you understood. Now in this current scenario, I'm trying to explain something like, if I if at line number 19, if I call this constructor, okay, if I call this constructor, line number 15 constructor will be called. Now if the business requirement says that, hey, from line number 15 call the current class constructor again, like if I want to call this constructor again from this constructor, okay, so in the previous scenario, by using super, you are calling the parent class constructor. But now from this constructor, I want to call the same class constructor again. So I use a different keyword called this. Okay, very good. So by using a keyword called this, I can call the same class constructor again, which means when I call this method, by looking at this symbol called this, it will call the same class default constructor for me. Okay, or anything. String str comma int win number comma string s1. Four parameters, right? It has three parameters it has. So if I want to call this constructor, so this of some string abc comma int 12 comma bbc, some string again, all these. Okay, so when I call this constructor will be called. okay, because of line number 16. Okay, now understand the concept and answer this question. What is the output for line number 19? Think before you answer. 19 only. P1, C4, C3. Okay, what about others? Very good team. So whenever I call this one, what will happen? It will call this constructor. What is the first statement in this constructor? Again, super. Because of super, it goes to the parent class, calls P1, the default constructor, then C4, then C3. Okay, let's see if that's right or wrong. See here, it calls P1, the parent class default, then C4, 3333, then C3. Okay, clear with the concept of constructor chaining, how the constructors are being called? Okay, now the next concept in this again. When I say this, it is a call, there will be no super in C3. Yes, the answer is correct. That's what I was about to explain now. Okay, so the concept at line number 16 is, because of the keyword this, what is the use of keyword this will call a constructor. Okay, the keyword this will help us in calling a constructor, and the keyword super also will help us in calling a constructor. Now the call to a constructor, can that be, or should that be as a first line, or can you write that at any line in a constructor? Any line. The answer is wrong. It is only the first line. Okay, only at the first line you can make a call to the constructor. So see this one. I say Control X. See what happened? Line number 18 is a call to a constructor. The concept is, a call to a constructor must always be first line at a in a constructor. Okay, at any place if you write that, it must be the first line always. So either writing super or either writing this at any other location apart from the first line in a constructor is wrong. Is that clear to everyone? Okay, now if that is clear, answer this question. Can a constructor have both super and this keywords at the same time? Good. The answer is no. Why? Because what is super and what is this? Both are calls to the constructor. When both are calls to the constructor, can they be written at second line? Okay, see, if I say that I will write super here, so it means that I'm contradicting the rule. Super is a call to the constructor which I'm writing as a second line. So this concept is wrong. If not, if I make something like this, now I'm contradicting the rule again. Even this is also a call to a constructor which must always be the first line. So again I'm contradicting. Yeah, super can be called by default only if you don't write this. Okay, so two things which must be written at the first line only can never exist at the same time. That is the concept. Clear? So any doubts before I proceed to the next concept?
So the solution to that is write to method.
No, means there is no solution to that method. So if you want to by default, see, if I comment line number 16, what is the immediate method that will be called?
The super.
The super class
Super.
default one will be called, right?
Right. Yes.
Okay, even if I write line number 16, what is the first thing that will be called?
This is gonna call the same class 1, 2, 3. The third one.
Same class, line number
Fourth
20,
one.
right?
20. Yep.
But will line number 20 be executed or something else will be executed?
The super will be executed first.
So ultimately, even if you write line number 16 or even if you don't write line number 16, are you getting the one by default, like the super one is being executed or not?
Right. Can you have like multiple methods from the same class called at the same time? Or?
Multiple methods?
Yeah, like
I did not get you.
so right now we have
So
1,
before
2,
you
3,
ask the
4.
question, just let me put it this way. Are you talking about a method or a constructor? So
I
please
mean
be clear on that
constructor.
and ask the question.
Sorry, constructor.
Mhm.
So can we have multiple constructor call at the same time from the same class?
Okay, so what exactly you want to call multiple times? So in the current scenario, when I am calling line number 19, I am calling only one constructor, which is nothing but the one at line number 15. But that internally calls line number 20, which means I'm making a call to two different constructors at the same time, which internally is calling the parent class constructor, which means three constructors are being called, out of which two belong to Mustang class and one belong to the car class. Does that answer your question or still no?
So I guess could you so I guess my last question would be like, could you put like this and then just the brackets and then have that call Mustang on line 20, line 21, I guess?
Okay, where do you want me to write this?
Right below 20, yeah.
Okay.
Okay, that'd be wrong. That'd be right. Okay.
Yeah,
So that calls the line 5. Okay.
exactly. This calls line 5, but what ultimately line 5 calls? What exactly that one will call?
The other class, the super class.
Super class
Default.
constructor. Okay.
Yeah. So if I written like this and then give some kind of string in it, it would call line 10.
Absolutely.
Okay.
Okay. It calls this constructor, and this will call, ideally by default it should call the default constructor, but we explicitly changed it to call the parent class parameterized constructor.
Right. Okay. Okay.
Clear? Is that good? Okay. Yeah. Now going back to the next concept, the most, and sometimes people get confused at this point, most easiest concept. So let me create a class from ABC class. When I create a class called ABC, understand that the super class for this class is told as java.lang.object. Java.lang is a package, we will see that later, but object is the parent class of all classes in Java. There is a class called object. Okay, there is a class called object in Java. So when I say finish, you will never see ABC extends object explicitly, but still that is a default feature in Java. Okay, I will explain more on this, but answer my question. What is the default class that ABC is extending? Everyone, what is the answer? Object with O caps. Okay, since it is a class name, the object should start with a capital O. Okay, so now let me show a simple example. So what is the class I have now? ABC. So ABC A equal to new ABC. Okay. Now, next question to everyone. How many methods are there in ABC class? 0. Okay. Since we did not write anything, the answer is 0 methods. Now, when I say A dot, how many methods will it show? So everyone assumes that 0, that's the right thinking. Why? Because till now we did not understand the concept of object class yet. So it should be 0. But see here, I say A dot. As soon as I say A dot, there are some public methods. Let's not worry about the method names or what is it taking as input. Let's not worry about any of these things. Just only understand what is the end class. So it says all these methods are present in object class, object class, object class, object class. So how exactly this is coming? Why? Because ABC by default, okay, not only ABC, every class in Java by default extends from the object class only. Okay, so ABC extends from object. So because of that, all the methods in object are shown here. A dot hash code. Okay, clear? A dot hash code. What is this hash code method? This means, let's not worry about the implementation of this. Just understand that this is a method given to you by the object class. So since object class has this method, and since ABC is extending from object class, nothing but a inherited method from the object class. So the parent class of all classes in Java is object class. Clear or not? Okay, let's see the object class, how it looks like. See, public class object. Okay, and it has some methods: register natives, get class, hash code, equals, clone, toString, notify, like that. It has certain methods which are defined in this class. Okay, object class. So these things we can use or inherit by default to any class in Java. So now why I told this concept is, when I say at line number 7, okay, at line number, okay, let's not take line number 7, start with line number 13. When I say line number 13, new Mustang, we know that it first calls this Mustang class default constructor, and before it executes anything, it calls the car class, or it calls the parent class constructor, which is nothing but the car constructor. And will line number 6 be executed directly? No, it will not be executed. Why? Because by default, again in the car class, the first statement will always be super, as we already discussed. Okay, it will always be super. Since the line is, since it is super, what happens is, it checks, does the car class has any super class of classes or not. Yes, the super class of car class is object class. So it creates an object for that, then it comes here, creates an object for class, car class, then it comes and creates an object for the Mustang class. That is how the object hierarchy happens. It goes till the topmost class. The topmost class in hierarchy is always the object class. So it goes till the object class, then comes and creates an object for the car class, then creates an object for the Mustang class. That is the hierarchy of calls, but we will never notice that an object class is being called. Okay, is that concept clear to everyone? Okay, yeah, that's good. So Any questions in today's class before we wind up the session? If it calls, object calls. Yeah, in object class there is nothing, right? In the object class constructor there is nothing like a sysout or anything to notify you that that constructor is being called. That is the reason why nothing is being printed. Even if I remove this sysout and execute it, this constructor will still be called, but you will never know that this constructor is called. In order to tell you, or in order to make you understand that this car class constructor is called, I am writing a sysout so that when this constructor is called, this is printed in the output and you can understand that. So this is just for your informative purpose. So if you see like any default constructor, it will not have any sysouts in it. So you will never know that there is a constructor which is being called. Okay? Yeah, go ahead with your question, Sai. Not a problem, even if it's not today's class. Oh, okay.
Yeah, I have seen this declaration. Yeah.
Yeah, I got your question, but integer is something which is belonging to a wrapper class. We did not come till that point, so I would like to explain the same concept when we go to the wrapper class concept. Why? Because we only saw, means in the first classes we understood that there are primitive data types and wrapper classes. We only covered primitives. We are yet to cover the wrapper classes. When we cover that, I will definitely explain this concept. Even if I forget, just remember me, remind me. I'll explain this. Okay.
Yes. Okay. Okay. And you just asked us to know something about intern method, right? In strings.
Mm-hmm.
Yeah. So can you tell something about intern method? Like what is the purpose?
Okay. So intern method. So did you go and check what is that intern used for?
Yes. Yes. I saw, but I did not got the complete clarity about that.
Okay. So maybe just go back and check again with a little bit of understanding. Intern is used for string comparison. Okay, when you're trying to compare strings, we can use that intern method. Just with this understanding, try to see the same old examples that you saw. If not, maybe tomorrow in the first part of the session, I will explain that intern, and then we'll go with the next concepts. Okay.
Yeah. Okay. Okay.
But why? Because on the other day, if you remember, we saw like how to compare strings. In general, we saw two methods like equal to and dot equals. Two methods only we saw, but I told you to check for the intern method, right? So it's also used for basically for string comparison. So I will explain that string comparison, how to do it with intern. Okay, like equal to and dot equals. I'm just stopping the recording. Okay, now we will see how to attach the source code into the Eclipse. So if you click on m1.hashcode or any predefined methods if you use, and if you press Control and click on that hash code, so if the source is not attached, it asks for a location saying that attach source code. Did you click on it?
Yeah, I did.
Okay, yeah, it asks to attach source code. So if you click on attach source code, okay, you need to select the external location and click on external file, and all you need to do is point to the location where you have installed your JDK. So go back to the location of JDK, and if you see inside JDK there is a folder called src.zip. That is what you need to say. You select it and say open, which means you are attaching a source to this files, to this dot class files. Say OK. So now you will be able to see the source code from now onwards. Did you notice? Like the object class given by Java is shown to you. Okay, this is how you can attach source code and all in your project. Now you can go to any class. You have a predefined class called system, or you have a predefined class called string that you are using on a daily basis, right? You can go to any class and inspect all the classes and inspect all the utility methods in those classes and all. Clear how to attach the source code in your project? Okay,
Yes.
I'm just stopping the recording again.